Hello and welcome back to my channel. So today we are going to solve some problems on limits as well as the sum derivative. So let's start with the first question. We need to find the limit when x is approaching 0 from the right hand side and the function is log of x minus log of sine x. Now whenever I write log, it actually means log to the base e. So x approaching 0 from the right side means that we have to find the right hand limit. So I can rewrite this function as log of x by sine x, right, due to the division rule, the quotient rule in logarithmic. So now limit x approaches 0. I can now x by sine x looks similar, but what if I write it as minus of log of sine x by x? It's the same thing. Now we know that limit of sine x by x is, when x is approaching 0, we know that limit is 1. So we know that limit of x approach 0 sine x by x is 1. So therefore this function will be, when x is approaching from the right hand side, limit of minus log sine x by x will be minus of log e to the base 1. So we get this as limit, and we know that e to the power 0 or anything to the power 0 is 1. Therefore this is true when e to the power 0 is 1. Therefore the limit will be 0. Yeah, I can rewrite this as equals to 0 because e to the power 0 is 1. So therefore the limit of log of sine x by x minus sine x by x is 0. So moving on to the next problem, we have to find the limit. Find the limit of x to the power 1 by log of x. So it's base e. So we need to find the limit when x is approaching positive infinity, or so I can let's put y as x to the power 1 by log x. Now if log of x is greater than 0, we know that the range of log of x is always greater than 0, so that means it's positive, it's on the positive side. Therefore 1 by log of x will also be greater than 0, right? Therefore this thing will be greater than 0. Therefore I can apply log, and I can rewrite this as 1 by log of x to the base e times log of x to the base e. So this one and this one will get cancelled out, so I am left with 1. So what it says is that log of y equals 1, which implies that e to the power 1 equals y. So that means there's only one way this can be true, is that when y equals e, so e equals y. So therefore x to the power, as I had shown before, as we had put y equals x to the power 1 by log x, so therefore y equals x to the power 1 by log of x equals e. Therefore this is a constant function. It has become a constant function. If I apply limit when x approaches infinity to e, it will be the same. It will remain as e, because e is equal to y, right? So the limit of this function is e. So moving on to the next problem, we need to find the derivative of a function using limits. So we only need to use limits and find the derivative of a function. So the function is given as under root x. Now let's say y equals function of x, right? So we y equals under root x. So we know that to find the derivative of function using limits, we know that dy by dx, or the derivative, is equal to limit h approaches 0 f of x plus h minus f of x by h. So here I can just put those values and let's say what we get. So function of x plus h will become under root x plus h, right? And function of x is already given as under root x. So substituting this in the formula, and we can write it as limit of h tends to 0, f of x plus h will become under root x plus h minus under root x by h, right? So let's say let's put a equals x plus h and b equals under root x. So here we have this in the form of a minus b by h. Now if I substitute h as 0, this whole thing will become undefined and will not get to know the limit. So to cancel out h somehow, we will simplify this, and let's say we divide and multiply this by a plus b by a minus b, right? We divide and multiply by a plus b, a plus b. So this will become a square minus b square by a plus b times h, right? A square minus b square is will give me x plus h minus x by h times under root of x plus h plus under root x. This can cancel out, so we are left with h by h times a plus b, right? I can rewrite the a plus b. Also h is cancelled out, so we can rewrite this as limit of h approaches 0 1 by a plus b, that is 1 by under root of x plus h plus under root x. So now if we, as h is approaching 0, we can substitute h as 0 here, and we'll get 1 by under root x plus under root x equals 1 by 2 times under root of x. So this is the derivative of the function using limits. Okay, so now moving on to another problem, we need to find the equation of the tangent line. Let me write this down. Find an equation of the tangent line to the graph y equals under root x at the point where x is 9. So we have given a function under root of x, and we can draw this on a graph, and at the point x equals 9 we need to find the tangent at that point, and we need to find the equation of that tangent line. So let's first make the graph and to better understand this. So making the graph, so the graph will look something like this, and this is the y, this is the x part, right? So at point 0 we have y equals under root x. So at point 0 both will be 0, the value of the function will be 0, so we have 0 0. At point 1 1 we have both 1 and 1. So at point, let's say 9, when x is 9, y will be 3, as y is under root of 9, right? So at this point we need to find the tangent, that is this line touching at this point. So we need to find the equation of this line. So how do we do that? We know by differentiating we can find the slope of this tangent at point x equals 9. So what we can do is we can simply take this function which we have y equals under root x, we can differentiate it, so we get y dash, the derivative will be 1 by 2 of x minus 1 by 2. Now this is the derivative. Now the derivative at point x equals 9 will give us the slope of the tangent line. So at x equals 9, this will give me 1 by 6. So this is the slope of the tangent line, or I can call it as m, or this is also y minus y naught by x minus x naught. Let me show you how. So the equation of a line is given as y minus y naught initial points equals m of x minus x naught plus c. So here when x is 0 and y is also 0, therefore this whole term will be 0, therefore the c in this part is 0. So we are left with y minus y naught equals m x minus x naught. So the slope of the line is we already know that m is given as 1 by 6. We already found that out. So we just need to formulate the equation of that line. Now how do we do that? We already have some initial points. We can take any initial point. Let's say we take x as 9, so that gives us y as 3. So the equation of the line will become y minus 3 equals 1 by 6 x minus 9. So this is the equation of the tangent line which touches at x equals 9. So thank you for watching this video. I hope you like it, and I will add this in the derivative sections. So thanks for watching.